Welcome to Probability and Statistics. In this lecture video, we're going to talk about your first project, rolling two dice. So what I would like you to do is take a pair of dice and roll 100 times and list all the sample space of the sum of the two dice you roll and record the frequency of each outcome. Alright, so what I want you to do is get two dice, right? And then start rolling them 100 times and then add up the sum and then begin to tally. So for example, if I got my two dice here, let me see. Alright, I'm gonna get my two dice here. Alright, so I got two dice, so I'm gonna roll both of them. Alright, so I got a 3 and a 6, so that will be the sum of 9. So the first thing you're going to do is the sum of two dice is your first column L1. So the sum of two dice, you start out with 2 all the way up to 12. So the sum of 9, I just roll, I will tally it one time. Now let me roll again. This is my second row. 1 and 2 together is a 3, so I tally under the sum of 3. Alright, so you do this for 100 times and you write, once you finish tally, you can write down your frequency and then find your relative frequencies. Alright, now for the next page on your project, what I want you to do is put the sum of two dice under L1 in the calculator, frequency put under L2. Alright, find your mean, median, mode, and your sample. I didn't do a good job here. I should use an S, but I didn't. Find your sample, standard deviation, and find your variance. Now the mode does not show up on the calculator, but you can look at your highest frequency, alright, to actually write down your mode. And you answer these questions for me, okay, like we discussed in the lecture videos. Now when it comes to the third page, you got to graph number 7. You got to graph the histogram. Alright, enter the sum like you already done, 2 all the way through 12 under L1, and write down your probabilities under L2. Alright, and your probabilities are referring to your relative frequency. Okay, you can type them in as a fraction or decimal, either way. Alright, and then I will need you to sketch the histogram by hand. So what I really want you to do is make sure you're able to label your X and the Y axis. Alright, and make sure you label this correctly. So let's pretend the first bar is about this high. Alright, the highest probability is about 1. So you got to scale your y-axis and x-axis. Then this will be the sum of 2. Okay. You can put a, let me just draw another one. You can just put a sum of 2 right here in the middle. Sum of 3, let's pretend sum of 3 is slightly higher, okay? Alright, so how many bars should you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bars. So you should see draw 11 bars. So I want you to put this under L1 and probability under L2. And then what you can do is graph your histogram in the calculator and then transfer on paper, where you will scale the y-axis and x-axis for me. Alright, so on the calculator, if we go back to section 2.2, histogram for group data, okay, so make sure, alright, make sure you understand how to do the x minimum. The lower class limit of the first class got to be 2, because that's my smallest sum. The upper class limit of the last class got to be 12. Alright, class width between each class, sum of 2 to 3, 3 to 4 is 1. y minimum at 0, you can set your y maximum at 1, because that's your that would be your highest probability. Okay, which is 100% 1. Alright, so after all, you should see 11 bars. If not, you gotta make adjustment on these numerical value to show that there are 11 bars. Alright, and then look at your histogram to tell me whether the graph is symmetric. Alright, number 9, the last question. Construct an empirical rule below. Does 68% of data lie within 1 standard deviation? So what I want you to do is write down, draw yourself, or I might have this on the handout. If I don't, draw yourself a empirical rule, the bell curve shape. Put your mean coming from number 1 here. Okay, put your sample mean here, and then use your standard deviation. Okay, use your standard deviation. Go to the right one, go to the left one, because that would be 68% of your data. Alright, I need to know what this number is. I need to see what this number is. And once you know what these two numbers is, go back to, well, let's just pretend that the mean is about, like, 6. One standard deviation to the left is maybe like a 4. One standard deviation to the right, let's pretend it's going to be like an 8, something like that. Alright, so you go to the 8 point something. So let's go to your chart, your first page. Okay, so let's say this is 4, 5, 6, 7, 8. So let's look at these frequencies, 6 all the way to 8. Alright, and let's see how many I got here total. Okay, if I add up all these frequencies and divide it by 100, see if it's come out to be let's see if it come out to be like 68%. Okay, it can be higher than 68%. Okay, it can be higher than 68%, that's fine, but I want you to notice, I want you to understand that the 68% of your data, okay, that means you roll 100 times, the 68% of your data is occurred, okay, between whatever standard deviation and your sample mean is located. Our majority of your data is within 1 standard deviation away from the mean. Okay, so that's why I need you to add these up, compare that to the total number of frequency, which is 100, and see if that's 68%, or maybe it's higher. Maybe you might have 90% of data is within 1 standard deviation away. Okay, everybody's project is different. Everybody, how you roll the 2 dice, everybody's a little bit different. So nobody should have the same answers. Okay, number 1, and on the experiments, and on this number 1. Alrighty, so if you have any further questions, make sure you contact me through email, or you can call me during my office hours.